Welcome to the lecture series Programming in C. We will focus on learning symbolic constants, overflows and underflows. In this module, we will be covering on how to define a symbolic constant, how to declare a variable as a constant, and we will learn on overflows and underflows. Also, we will be learning about how to prevent or how to address overflows and underflows. Symbolic constants. The symbolic constants are going to be the representation of the constant values in the program. Say for instance, if I am using a value for pi representation, pi is going to carry the constant value 3.14. So, wherever supposing in a program, if I am using the pi value for calculation say many times, say for instance 10 times in a program, I am supposed to use the pi value. So, every time instead of giving the pi value to be 3.14, we can assign some name to the value or some name to the constant. So, instead of 3.14, I can make use of the symbol as pi. So, wherever I am supposed to use the value of 3.14, instead I can make use of the symbol pi. Even though it has a sequence of characters, we call it as a single symbol. The constant which is assigned to this symbol is called symbolic constant. How we will be able to declare the symbolic constants are through C preprocessor directives. So, why we are naming that as preprocessor directive is that we are supposed to give or assign these constants prior to the compilation. The compilation of a C code starts from the main module, or when I am supposed to give the main function. This is where the compilation of the program starts. However, if we want to do something prior to the compilation, we can declare those things as preprocessor directives. So, these preprocessor directives are one of the way of creating symbolic constants. The preprocessor directives will begin with a hash symbol. So, it should begin with the hash symbol as mentioned here, and only white space characters and comments can appear before the preprocessor directives. So, the preprocessor directives, when it is used with the define keyword as hash define, this is used for creating symbolic constants, and the macros are used for creating symbolic operations. The hash define preprocessor directive is used to assign symbolic constant to a symbol, and macros are used for defining a set of operations, and those operations can be named with a symbol. So, we are just going to focus on how symbolic constants can be handled in C. So, hash define identifier name, any name which we want, and what that name is to be replaced, in how many occurrences it can be replaced. Okay, generally by default, for all the occurrences in the file, wherever it encounters that particular name will be replaced with the replacement text. The replacement text can also be a numerical value or can be a floating point constant. So, the example is given here, hash define pi equal to, or pi it is 3.14. Here we are not supposed to use the equal to operator, otherwise it becomes an assignment operation. Here the operation has to be done before compilation. So, we are not supposed to use as we are using the assignment statement. So, here, so the compiler will be able to replace the places where the symbol pi is used with the value 3.14. Why we should do this? What is the necessity or what is the advantage of going for symbolic constants? The constant value is going to remain the same. I am not going to change, or we will not be able to modify the value of the constant. Then in the program, if I am declaring a constant through a variable, say for instance, I declare a variable float type for storing the value of pi, and I am assigning the value 3.14 to it. So, what happens at the compiler end? This will create a memory location and the value 3.14 is stored in the memory location. Now, I am going to use the value pi maybe 10 times in my program. Say for example, I am going to calculate the value, or I am going to multiply 10.5 with the pi value. So, here what happens? The compiler should go in search of the memory address with respect to the variable pi, and it has to fetch the value from the location. So, the value of pi will be fetched from the memory location in replacing for the execution of this statement. So, here the compiler requires one memory cycle for, or one execution cycle for searching the particular memory address, and it has to fetch the value from that memory address. So, in this case it requires 2 operation cycles. However, instead when I am using, or when I am defining that as symbolic constant, just the replacement occurs here. The process of going on in search of the memory and fetching the value will be just replaced, will be cut off. Instead, wherever the symbol pi occurs, it is just treated as a symbol, and the value assigned to the particular symbolic constant will be just replaced in the positions where we use pi. So, wherever I use the symbol pi in my program any number of times will be just replaced with the value 3.14. So, this avoids searching the memory location and fetching the value. So, those 2 executions are avoided, so that the computational time can be minimized. This is the advantage of going for symbolic constants. So, this is what we have right now seen. If at all, if we are declaring the pi value as a constant type variable. So, the const keyword can be given here before or as a prefix of the pi variable declaration. In this case, it is declared as the constant variable. This may not be treated as symbolic constant, whereas symbolic constant will just replace the values wherever it is referred. Okay. So, for that we will be using hash define as the preprocessor directive to make it as a symbolic constant. Supposing, assume that I go for declaring a banking application to calculate the simple interest. For calculating simple interest, the rate of interest can be defined as a symbolic constant. Supposing when I am declaring the rate of interest as the symbolic constant, the rate of interest I will be using the symbol hash define. I will again rewrite it in a better way. So, I will be using hash define ROI rate of interest with 10.5. I used to calculate the simple interest with the formula PNR by 100. So, for doing so, instead of this R, we can refer to the symbolic constant ROI. So, what happens every time if the rate of interest is going to be fixed, then there is no problem, we can move with the symbolic constant. However, if the bank is going to change the rate of interest, we are supposed to even change the value of ROI. So, it is enough that I change the value here at the time of defining it as 9.5, but still this requires the modification in the original program, which may not be available for execution. So, in those cases we can go still as defining the constant type variables. The constant type variables will also be doing the same process, but then it even be following the properties of a variable. Okay. So, for such application it is preferable to go for const variable declarations. So, we can be, this is again an interesting thing that C allows us to have some more preprocessor directives. One of that is hash include. Hash include is a preprocessor directive by which you can even supply the file names. So, the way that hash include allows the file names to be given as input is hash, either you can go for using it as hash include within angle brackets the file name, or hash include within double quotes the file name. So, there is a difference between these two notations. If the file name is enclosed within double quotes, the processor will start searching for the file in the same directory or current directory. If we are giving it in the within the angle brackets, the file location will be searched by the compiler by itself. So, that is a difference between giving hash include and using two different notations. Now, assume that you have defined a symbolic constant. We generally use or have the practice of defining the symbolic constants in the program, but then at the time of using the program, using the constant, we should be clear enough that whether we have defined it or not. So, there is a way that the presence or definition of the variable can be verified by using the preprocessor directive hash if. It is called conditional compilation, because based on a condition we can make or we can assign the constants, we can assign the symbolic constants through hash define directive. So, this hash if will check whether we have already defined the symbolic constant my constant. If it is defined, if it is not defined, this not symbol will allow you to check if it is not defined. If it is not defined, we can go for defining the value of my constant to be 0. Okay. Since this preprocessor directive starts with hash if, it is a conditional statement, we have to close it, we have to close the condition by ending it up with hash end if. So, this is how the conditional compilation can occur with respect to the preprocessor directive hash define, to define or to play with the symbolic constant. Next, we will now see the conditions of overflow and underflow with respect to the values. We started defining the values, we will be assigning the values to the variables through data types, but still there may be a situation that we can encounter overflow or underflow. Overflow occurs when the value of the variable is too big for the data type to hold. Underflow occurs if it is too small to hold. Okay. So, these are the two major conditions that has to be addressed. Why it need to be addressed, that we will now see with the examples. So, this example you can see int a is assigned with the value which is the maximum value for a signed int. Then it is added with the value 1. So, if it is added with the value 1, int will not be able to accommodate that value, because it becomes now 2147483,648, which is more than the maximum value of the signed int. Then this condition results in integer overflow. Then there is a second case that the same way we assign the maximum value of a signed int to a variable, and now we will try to divide that value by 0. So, this actually ends up with the situation called division by 0. So, any number divided by any number divided by 0 results in infinite. We all know that, right. This infinite situation cannot be handled by the C program. Hence, it results in the overflow situation again. This may lead to a overflow error even in this case, division by 0. The next method is typecasting. What I am trying to do here, I am trying to convert the value of one type of data to the other type. Say, assume that I am trying to store an integer type data to a short int. The short int by size is lesser than the int type. So, what happens when I am trying to accommodate a larger number into a smaller data type, this cannot be, or the smaller data type will not be able to accommodate a bigger number. So, again in this case this results in integer overflow. Say, for instance, the maximum value is stored into an integer type variable, and we are typecasting that, we are trying to convert that to a short type variable, and we are trying to store it in a short type variable b, short type variable b. So, if it is short type, which will not be able to accommodate this much bigger number. So, obviously, this will also be resulting in overflow. And so, this is one more situation where integer overflow will occur. Assume that I am trying to get or read a value from the user using scanf statement. So, using scanf statement, I am trying to read a value from the user and I am putting it into a variable named a, and without even knowing what sort of value the user is going to give as input, the result variable is assigned with the computation of a by 10 by multiplying it by 10. So, assume that a is actually an integer type variable. Suppose if the user is giving the maximum value for a, and if it is multiplied by 10, the result is also defined to be an integer type variable. So, it will not be able to accommodate the computational result. So, this again will result in the overflow situation. There is one more important case, and this usually will occur. So, supposing if we are ending up with indefinite loops, this will again result in integer overflow. Say, for instance, I is declared to be an integer type variable, whereas I go for using a for loop. The for loop is initiated with I value to be 0 and it is incremented with the increment statement. I is incremented by 1, and we are checking the condition that I is greater than or equal to 0. Initially I is assigned with the value 0. So, for the first time the condition of I equal to 0 becomes true. So, it executes the loop body and the increment process is carried out. So, when it is incremented, now the I value becomes 1. So, we can check that this condition is always true. If this condition is always true, the condition of I being greater than or equal to 0, if it is always true, the value of I will not be able to accommodate the maximum range, because there is a limitation for I value, because it is defined as int type. It can go only up to the maximum of the range that int supports. If we are trying to increment the loop even more than that, obviously it results in the overflow situation. This is actually a dangerous situation, because the loop body will keep executing. It will not be able to get out of that loop. The situation will be very dangerous, that it will result in hang of the system. So, this will again be considered as the overflow situation. There is also possibility of having integer underflow situation. So, in the case of having integer underflow, because an int supports both negative as well as positive range of values. So, if you are using the minimum value for assigned int to be of minus 21, 47, 48, 36, 48, this is a minimum range of assigned int. If this is the case, then if we are trying to decrement, or if we are trying to apply the subtraction operation with value 1 or any number, then it may again result in underflow situation. This will go down, because this value, this negative value is not applicable in the given range of int. So, this type of problem will result in integer underflow. So, what we are going to do, what is going to be the impact of these overflow and underflow situations? We will be encountering three major problems. One will be, the first will be the data corruption, in the sense what is the output that we are expecting will not be the actual one what you are getting out of the program, because somewhere or other in the loop or in the integer assignments, the value of the variables gets altered because of this overflow or underflow situations. So, the program will not behave in the predicted manner. What is the output that we are predicting will not be the one which we are actually getting out of the execution of the program. So, this will be the data corruption error, and there may be some sort of security vulnerabilities. So, one common vulnerability will be buffer overflow issue, in the sense the security problem will happen, or supposing of a third person or an intruder or a security attacker, if he is trying to intrude into the system, the simple way to do is that you can generally, or you can easily create a buffer overflow. Okay. I create a program, in my program I get the value from your compiler, and I am trying to just increment the value in indefinite times. It results in the overflow attack. So, obviously, I am trying to make your program untrustworthy. It will not work. I can make your program not work properly. So, this is one major problem with respect to security of the program. And as we have already discussed, it may result in abrupt termination of the execution. If we are encountering the overflow through loop executions, it may crash or terminate the program execution. So, if the program is abruptly terminated, the consequences will be very poor, such that the values in the memory location will be erased irrespective of any sort of situation. So, that will lead to lot of subsequent problems. So, we are supposed to prevent these overflows or underflow problem. So, how we are going to do it? There are few methods to be adapted in case if you want to prevent overflow or underflow problem. The first step is, we have to use appropriate data type, in the sense that if we want the expected range of the data to be 32 bits, we can define or redefine the integer type to accommodate 32 bits only. If we want it to be more, we can even define it for 64 bits. So, this way we can do changes with the data type int 32 underscore t, int 64 underscore t. These are the ways that you can change the range of the integer type variables. But then this is not done with the usual stdio.h header file. stdio.h header file is a standard input output operations. This is not a standard operation. So, we need additional header file which is stdint.h header file. So, with the header file support, we will be able to change the size of the data type to 32 bits or 64 bits according to the expected range of the integer value. Then one more method is to go for checking the bounds. Before doing any operation, it is better to check the bounds of the variables. Say for instance, I am trying to apply the multiplication operation. So, for which I am using the variables a and b. So, before handling the variables for multiplication, I am checking the bounds of the variable. So, a should be greater than 0, b should be greater than int max by a, or the other condition can be this is OR operation, or the other condition can be a less than 0 and b should be less than the maximum range. So, by checking these things, by checking the boundaries of the ranges, if it is satisfied, if we are multiplying or going ahead with any of the operations, then successfully we can avoid the overflow. Okay. So, overflow can be detected by checking the bounds of the variables. The next way is, while compiling the program, we can use certain flags. W is one of the overflow flag by which we can make the compiler, or we can instruct the compiler that if there is going to be any overflow, please give me a warning. So, in this case, instead of abrupt termination, the compiler will take in charge of checking for the overflow condition. If there is a overflow expectation, immediately it will be giving us a warning instead of abruptly terminating the code or execution. One another method is to check for the range while doing the calculations. So, by the check, the limits can be checked. For doing so, we are supposed to use a header file called limits.h. So, every time before calculation, we can verify the range, whether it is in the range or not. Once if it is inside the expected range, then you can go ahead with the process of doing the computations. By doing so, we can avoid the overflow conditions. So, summarizing on this session, we have learnt on symbolic constants, how to define symbolic constant, what are the advantages of defining symbolic constants. We have used preprocessor directives, say hash define preprocessor directive, and we have seen hash include and hash if and hash end if to verify the symbolic constant definition process. So, it has helped us to learn about the symbolic constants in detail. And we have also learnt about the very serious conditions of overflow and underflow while declaring the variables. What are the things that has to be kept in mind in case if you are going to declare a variable, how to go with the correct range of values used for calculations, and how to avoid the overflow and underflow conditions. The various ways to prevent this overflow or underflow conditions is to use appropriate data types and to go for bounds checking, and then we can use compiler flags or we can use range checking calculations. So, this is how we will be able to avoid or prevent the overflow or underflow situations while declaring or handling the data through variable declaration and data type declaration. Thank you so much for listening to this session. Thank you.